let's talk about sector area. So a sector of a circle is just like when you take a circle. Oops, sorry. I guess that was a preview there. It's when you take that circle, you start from the center and you cut off a sector or like a pie piece. So we'd be trying to find the area of that. Now, just like when we were trying to find the part of an arc length where we took 360 and we said, hey, whatever our angle is, divide by 360. We're going to do that again, except instead of multiplying by the circumference formula, we're going to be multiplying by the area formula. If you're given your angle in degrees, which unless you're in my pre-AP class, you are, you're going to see it like this. If you're given your degree in radians, you just get 1/2 r squared times your interior angle, which is pretty cool. And if you wanted to find the area of the segment, which would be like one of these things, all we'd have to do is compute the area of the sector and then subtract the area of that triangle from it. We're not going to be working examples like that in the non-pre-AP class or in this video. Let's talk about this example. So it says we may use pi in our calculator. We want to round our answer to the nearest tenth. We want to find the area of the shaded region. So our degree is 78. So we have 78 over 360 times pi. R is 13 squared. This will give me 114.9763, blah, 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 blah. Okay, if we're rounding to the nearest tenth, that 7 is going to make the 9 round up, and we're going to write our answer as 115. It doesn't give us units, so I'm just going to say units squared. And this is how we find our area every time. So it's our normal area formula. And we have to multiply that by the fraction of what fraction of the circle we are actually considering. Let's move on to a new topic. Let's say we wanted to graph a circle. So let's say we wanted to graph a circle with a radius r and a center at x1, y1. So x1, y1 are just known values. Then this is the equation that we will use that we could plug into, say, Desmos or some other graphing property in order to produce a circle centered wherever we want, as big or as small as we want it. Let's do some examples. It says, write the equation that can be used to describe the circle with the following. Okay, so we give our center, we give our radius. One thing to point out is that everything is squared. So I'd have x minus my x value, which is 1, plus y minus my y value, which is 0. These are both squared. And then we have equals our radius, which is 6, which is also squared. Okay, now they did some simplification here, obviously. Because let's look at the y minus 0. Well, 0 doesn't do anything. We don't care about it. Very sad. Poor neglected 0. So we can just leave that as y squared. Now, 6 squared, we actually know what that is. 6 times 6 is 36. So our answer is right here. Okay, let's do another one. It says, write the equation of a circle based on the given center and radius. So we have x minus our x value squared plus y minus our y value squared equals our radius, 5 squared. Okay, let's do a little bit of simplification. Again, if you're subtracting a negative, that's the same as adding. So I'm going to switch that. And I'm doing that twice, just so I can type less in and get more math. And then 5 squared is 25. There is the equation of this circle. So if we say plug that into a Desmos or some other graphing calculator, that's going to put our point, our center of our circle at -3, -1, 2, 3, 4, 5. So our circle would be centered here, and then it'd have a radius of 5, so it'd go about that far. So that's what our circle would look like based on this equation. Okay, this one says, which equation can be used to describe a circle with the following radius? Okay, so I would start off by saying, okay, we've got x minus 6 squared plus y minus my y value, which is 1 squared, equals my radius, which is 2 squared. But nothing like that is pictured below. So it turns out what they actually did was they actually squared these terms. Now, when you square something, you need to multiply x minus 6 times x minus 6. You'd have to do the same thing with y. Y minus 1 times y minus 1 equals our 2 squared value, which is 4. Okay, now let's use the array method in order to multiply these expressions, because distributive property is kind of hard to see when it gets this complicated. So what you're going to do is you're going to write down your x minus 6. So just write down your first formula and your x minus 6, your second one in the vertical axis. And it doesn't really matter which way you put those since they're the same. And then you're going to make kind of a times table for yourself. Well, x times x gives me x squared. And I'm going to also multiply this x by -6. Well, that'll be -6x. Okay, now let's multiply everything by -6. -6 times x is -6x. And -6 times -6, well, negative times a negative is a positive. So we have plus 36. So I'm going to write down this part as my product, or once I've squared, x minus 6 squared is x squared. Now we have -6x and another -6x. That's -12x altogether, plus 36. So x minus 6 squared is x squared minus 12x plus 36. There's a lot going on there. Let's do the same thing for y. I'm going to have my y minus 1, y minus 1. Multiply everything by y first. Y times y is y squared. Y times -1, negative y. Now let's multiply everything by -1. -1 times y is negative y. -1 times -1 is positive 1. Okay, again, I'm going to take everything that I just multiplied and write that as my product. So that'll be plus y squared minus 2y, because I had a -y and a -y. Together, that's 2y, plus 1. And that is going to be equal to, carry down that 4. Okay, now we need to actually simplify this a little bit so that we can compare. We need a -4 from each side. We need to combine like terms, because you notice all of these are equal to 0. So let's combine like terms first. There's only one x squared, so I'm just going to write down the x squared. And there's only one y squared. So I'm going to write those down first. There's only one quantity with the -12x, that's fine. There's only one y quantity, -2y. But we do have a 36 and a 1. So I'm going to write plus 37 equals 4, -4 from each side. That way we can get it equal to 0. And we'll have x squared plus y squared minus 12x minus 2y plus 37 minus 4 is 33. which appears to be right here. Now, as we're looking at this, you might say, hey, that looks a lot like some of these other formulas, but as you look closer, you'll notice that they switched up the coefficients here with x and y, so that's why that one's wrong. If you look at this one, it made everything positive, but there were negative numbers in there, so that's not right. And then if you look at this one, we randomly have a 35. Not sure where they got that. Okay. Let's work another example because that was a lot to unpack. It says, which equation can be used to describe the circle with the following center and radius? So I'll start off with my nice x minus my x value, which is 2 squared, plus y minus my y value. Well, in this case, minus negative 3, so I can put plus 3 squared equals 7 squared. Okay. 7 squared, I know is 49, so I'll just kind of write that down. Let's go ahead and do our squaring again. So we'll do the x values first. And now I'm going to be multiplying x minus 2 times x minus 2, because I'm multiplying it by itself. Multiply everything by x first. X times x is x squared. X times negative 2 is negative 2x. Multiply everything by negative 2. Negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. Okay, so again, just like before, all the things we just created by multiplication, we're going to be putting those in a row. X squared minus 4x, because there was a negative 2x and another negative 2x. That's a total of negative 4x plus 4. Okay, we're going to do the same thing with our y values. So we'll have y plus 3, y plus 3. Multiply everything by y first. Y squared. Y times 3 is 3y. Multiply everything by 3 now. 3 times y is 3y. 3 times 3 is 9. Okay, so that's going to be plus y squared, because again, we're just going to be writing down everything that we just multiplied to create. So y squared plus 3y plus 3y is 6y plus 9y. And then we'll just carry down 49 degrees. Sorry, not 49 degrees, 49. Okay, from this point, we can actually solve this. Let's do some combining like terms. I'm going to list my x and y squareds first. So I know I have 1x squared and 1y squared. I only have a negative 4x and I have a positive 6y. And then I can combine that 4 and that 9 to be plus 13 equals 49. So let's minus 49 from each side. And that will give me my equals 0 that I need. I'll have x squared plus y squared minus 4x plus 6y. 13 minus 49 is going to end up being a negative number. And it's going to be a negative 36. Okay, so that gives me this as my answer. That's all for today. Good luck.